now. Okay, so hello everyone, and thank you all for joining us. I'd like to start with a question, please. So please raise your hand if you'd like to be able to easily simulate network traffic over your real business services at any scale you need, whenever you need to. Please. Thank you, guys. This is basically what we set out to do a while ago here at LivePerson. And this talk is meant to, for us to share with all of you basically what we learned so far and where we've gotten so far with our solutions. So I really hope this talk inspires you to in solving similar problems to what we encountered in your own organization. Okay, so let's start. My name is Ori Cohen. My role here at LivePerson is a lead resilience engineer and also leading the team for traffic generation infrastructure. I'm a proud father to Amit and Eran and husband to Anat. A big passion for me is solving real-world complex problems via software solutions. And this is much of what I do here at LivePerson. Asher Holder, sitting here, will be co-presenting this talk with me. Asher's role here is a traffic generation infrastructure engineer, and he'll present himself once he takes over. Right. So I'd like to start by by defining what we mean by simulation here at LivePerson. Our definition goes like so. Simulation is synthetically generated network traffic, generally HTTP, HTTPS, and WebSockets, in patterns that can reproduce with great accuracy real users' network activity pattern over specific externally exposed APIs. Can any of you think of any example that would that would fit this definition? Anything that you might be doing in your environments or in your test environments? Anybody? Please? Okay. Right, so a few examples would go like load testing, for example. Service health evaluation during resilience and chaos testing. Distributed denial of service simulations, monitoring, and so on are examples, and this is by far not an exhaustive list of what would classify as simulations under the definition. Now, there are some challenges, though, when creating simulations. And I'd like to point out three main challenges that are important for this conversation. One is that in order to simulate real user activity, you'd need to analyze the traffic coming into your production data centers. And you'd need to break this traffic into patterns that you can reproduce during simulation, using simulations, and that would represent common patterns of the users. And in addition, afterwards, you'd have to find out the percentage of the traffic actually coming from any one of those common patterns. The second challenge I'd like to point out is that APIs keep getting added to your system all the time. Now, this over time changes users' flows through the system, and this would need to be represented in the simulations that you would use to simulate traffic over your system. The third challenge I'd like to point out is that real user activity is complex by its nature, because real actual people conduct these activities. So simulations need to be complex as well in order to correctly represent those behaviors. Okay. So now that it's defined, I'd like to make an important statement. Reliable service is what we are paid to provide to our customers. This is not something to take lightly, so this is a very important point I'd like to clarify at this, at this point in time in the lecture. Pushing changes of a service into full production without first verifying that the service works after this change, that it interacts well with other services, while accurately simulated user traffic is flowing through the system, through the entire system, for a sufficient amount of time in a in a staging environment without verifying that, pushing that kind of a change to production is dangerous, irresponsible, and really not something you would want to be doing. Now, most of you probably know this for a long time now, that testing changes on your development environment on your laptop and seeing that everything works fine does not qualify for and does not guarantee that those changes will work well in production. So you would need simulations for that in order to make sure that it will work. A wise man once said, with great scale comes great responsibility. I hope I'm not saying it wrong. At LivePerson operational scale with around 3 billion sessions and 200 billion API calls per month, over around 10,000 virtual machines and containers in 7 data centers spanning 3 continents, there are really so many moving parts, it's insane. At several occasions, we had to conduct several distributed simulations that fired requests from several Amazon data centers simultaneously for a few hours. Altogether, per simulation, we conducted almost 1 billion requests, and we did that via the solution that we'd like to present to you today. So that's kind of a solution to the complexity I'm presenting here, operational complexity. We have over 130 services developed here at LivePerson, developed by around 30 development teams in multiple development languages, Java, JavaScript, Scala, and so on really a very wide stack of a very wide technology stack. Configuration, real-time, offline data processing, really all of it. And just as an example for a simulation there, we have CI tests, CI system tests that we currently conduct that simulate traffic over producers and later check Hadoop cluster to make sure all data reaches that Hadoop cluster and that the data is processed as expected. So to do that, we use that solution that I'll shortly describe. So mostly when a person will need to access a simulation, they need to run that simulation in a specific load setup on a specific, one or more specific environment. And they'd expect this task to be as painless, as easy, and as automated as possible. If it could be just a few clicks of a mouse and to be able to launch that simulation directly and push traffic onto the production environment. That was something that we had to accommodate for very early on in providing a solution, even in the design of the solution. Other users would need to add simulations or modify simulations, and those developers normally want to be able to find the place in the simulations they need to make changes in as soon as very quickly, and very easily to find that location. And once they find it, they want to be able to make the change as quickly as possible and as effortlessly as possible. So that was another thing we had to take care of. Now, R&D has a very integral part in that, because R&D are basically the people that are in charge of the services pushed in production, and they know best, each team knows best how to simulate traffic over the service. So having them write those simulations was something that we realized that we had to have this integration. We had to have R&D create those simulations, and we would provide the infrastructure for that. But just try to think of a scenario at which we'd go to a developer or a team leader and say, I'd like you to please create simulations for me, real users and real user scenarios, and I'd like you to simulate activity over your services. That's not something that users would be able, developers would be able to positively respond to. They're usually extremely swamped with work. Normally, the response that we would get is, come back to us in a month or two. We have a release to deliver. I can't even discuss this at this point. And that's kind of their way of saying, get out of my face, I cannot handle this at this time. So it was clear to us at that point that we had to provide a lot of value back to R&D in order to get their cooperation. So that's also something that we wanted to involve in our solution. So the value we wanted to we decided to provide this value in the form of a consolidated platform for simulations that every engineering team, every development team would be able to contribute into. And all this contributed content, all those simulations in that repository will be usable for the entire organization. Everybody from every department in the organization, and I'm not referring only to the R&D organization, would be able to use these simulations. So, yes, please?
What do you mean by simulations? Do you mean like client components?
I'll give example. I'll give again examples in really a few moments.
Okay.
I don't want to get into the details yet, but you'll see very soon. Okay, if you have questions at that point, I'll be happy to answer. Okay, so what we decided we should do is that we would develop a very easy to use and a very simple infrastructure for developers to use, and the developers would provide the simulations. So in a system at which microservices are such an integral part, providing a simulation platform for everybody to use was really a huge proposition. It was something that was going to propel the entire organization forward, provide a lot of integration between teams, because the way it works at LivePerson and in many organizations that have a microservices approach is the team depend on each other because their services heavily interact in the production environments. So if I would, for example, provide to one team the ability to simulate other services interacting with their service in a test environment or any other environment, that would be a huge deal for them to be able to see how every change from every stage in the development cycle, how their changes interact with other services on real simulated semi-real activities. Right, so the way we decided to go technically with that is to provide a modular code-based solution. Modular, so the teams would be able to have their dedicated modules. For example, a team would that owns service A would be able to have a dedicated module within the shared large code base, specifically for service A, right? and they would provide all the simulation options, all the building blocks basically in that module, and all the other teams would be able to use that module later on for performing simulations over this service. Code-based, so all the development teams have familiar development environment for creating their simulations and using those simulations. It would be the same development environment as they use to develop their services day to day. So that's also a big plus. We wanted this framework to provide a lot of value in as many use cases as possible, and we saw a big opportunity there. So just as a few examples, we talked about load testing and stress testing, and many other types of this variant are tests that are run by performance teams. So there is value there for performance teams. Simulations of this type can be used for system testing and performance regression testing, otherwise named continuous performance tests. Those are used by R&D, and they can benefit R&D in that perspective. It can be used for demo to customers, so they can be used by the sales teams. For example, it can be used for resilience testing by site reliability engineers, DDoS simulations by security engineers, and so on. There are a lot of examples we could cover. So we really wanted this to be to provide value as widely as possible to the organization. And to really be able to do that, to really make an impact as wide as possible within the organization, we realized we must do the tooling right. We must make it as easy as possible and as quick as possible for people to be able to run simulations, for people to be able to add simulations. And we needed to, in addition to promote this framework and the tooling around it, as widely as possible within their R&D organization, so they would contribute back to this framework and to the platform. And so we would be able to create more and more value as this platform grows. So additional requirements, we realized we had to embed into the system, in addition to having it be a platform. Several types of simulations, such as distributed denial of service and extreme load simulations, require that this framework and the platform that runs on top of it be really as efficient as possible in terms of resource utilization. The less efficient it is, basically, the more costly it is to run any simulation, and we wanted it to be as efficient as possible, also from a cost perspective. We also needed our simulations to be environment agnostic, which means the code itself doesn't know where it's going to run, so you can run it on your laptop, you can run it in CI, in a test environment, in production, any production environment, and so on. And pre-runtime of the simulation, you'd simply specify what is the target environment, or if you have multiple ones, you can specify it there. And when you run, it will only flow traffic to those selected environments. Now, finally, in such a big platform containing so many building blocks, components that can be combined in what would seem currently in our platform an infinite number of combinations that can be run on multiple combinations of environments, and basically any load setup required. We realized we had to have very granular configuration to define what would be run at the simulation runtime. So the tool we realized we would need to use at that point, and we selected to use to base our framework on, is called Gatling. Gatling is really an amazing load test framework. For those of you who are not familiar with Gatling, it's a very active open source project. From the last time I checked, it's got around 6,600 commits so far, 85 contributors, and 2,600 stars on GitHub. It's a code-based framework. It has a very easy DSL to use, very clean, very easy to create simulations, and it's written in Scala. Now, Scala runs on the JVM, same as Java. And most of the code here at LivePerson is developed in Java, so it was a very clean fit, so it could integrate into our current systems. It's also the most load generator that we have evaluated so far. In comparison to the most common load testing tool we are familiar with, Gatling was able to generate a request rate 10 times more frequent, 10 times more requests per second than that tool was able to generate. Gatling also auto-generates reports, which was very big for us. Those reports are very nice to read. You can present them to management. They have all the information that's required in order to analyze what happened during the simulation. I'll demo this type of report later. It also plugs to CI, so you can use it for system testing and so on, like I explained before. And also plugs into time series DBs, so you can push metrics from your simulation onto this database to see both in real time and afterwards what's going on in the test. Okay, so I explained what Gatling is, but why did we choose Gatling specifically? Why not other tools? Well, when we started evaluating basically a bunch of tools for to be used as the base for a framework, we already had 2 development teams using Gatling for small-scale load testing and functional under load testing. So they brought Gatling to our attention. We weren't familiar with Gatling at that point in time, so we started POCing it alongside the other tools we evaluated. And very quickly on, we realized we had a very large learning curve in order to integrate Gatling as the base for our framework. It would take a lot of time and a lot of effort, and it didn't seem like the right fit at the time. While other tools were really easy to create simulations and the ramp up was really nothing. Gatling seems like it took a much more effort in order to do that. At around the same time, a little bit later, we were notified we're going to have a huge customer, a very, very large customer, join our product, our new product, LiveEngage 2.0. It was going to happen within a few months. This customer was really a huge customer. It was at the time the largest single customer that we had on our new product. In fact, it was so large that it was that the traffic it would generate was more than the entire traffic of that data center combined, all the other customers on that data center combined. So we realized we had to start producing simulations. We had to do this fast, and we had to produce simulations that would be able to generate traffic at an unprecedented scale for us. That brought us to realize that our traditional tools for load testing were really not up to the task. So we had to revert back to Gatling. And as soon as we did that, we quickly figured out that we were wrong to dismiss it initially, because the adaptability that Gatling brought to the table, the configurability, the flexibility of what we could do with Gatling allowed us to create the really modular and tremendously complex simulations that we had to build over Gatling in a framework fashion. And later, those simulations ran at truly incredible scale. in order to really be able to have our platform run on the scales we needed to, we had to make a few leaps forward in terms of our mindset, in terms of the tools we used. And it was really a natural choice to go to the public cloud for generating this traffic. But just using the public cloud as it is, deploying our runtime packages, our simulation runtime packages, was really not enough. It was too costly to simply place our Gatling packages of the platform on all the machines, on all the data centers, and then just at every simulation going to all those machines and collecting the reports and then aggregating them. That would be a nightmare. That was not something that we could do. So we went to a tool called Redline 13. It's basically software as a service that's provided over their website. What they basically do is it allowed us to create distributed simulations over EC2 machines. Really, within minutes of notice, we were able to spin up hundreds of machines and launch simulations there with only a few clicks of a single person. And that was really a big save for us. Redline 13 also collects metrics from all those machines that are running the simulations, and they're shown to the user running the simulation at runtime, so they can see in real time what's going on with the simulations, what kind of traffic are they outputting, what are the response times, and so on. Redline also collects the reports at the end of the simulations, of the Gatling simulations. Gatling generates a report per machine, and Redline 13 collects all those reports from all those machines, aggregates them, and provides a downloadable file for the user running the simulation as an aggregate report for all the machines that ran. The way this actually works is Redline 13 spins up machines as they need to be used by the simulation. And as the simulation completes, Redline 13 also disposes of those machines. So those machines are up, and you pay for them only for the amount of time the simulation runs. And in terms of cost, it makes the cost almost insignificant unless you're running really really imaginary loads. So in addition, if you want to even save more money, we're able to just check a checkbox on the Redline 13 application and switch to using spot instances virtual machines. Spot instance virtual machines reduce the cost even further by using the extra capacity Amazon has that they have in terms of their quota. Now, Redline 13, when we wanted to start using it for our Gatling platform, they didn't support our runtime packages. So we started conversing with them. We provided them with the source of the framework and a few runtime packages. And over time, we adapted with them. We adapted the service. And currently, on their website, available to everyone, Redline 13 supports our runtime packages. To wrap this slide up, when you run extremely high load simulations, sometimes you get at normally very low frequency, you get errors returned from the backend APIs that you work against. And even at a very low percentage, when the scale is very high, the amount of errors that are being logged onto the log files is enough to fill up the disk space and in turn cause the simulations to crash immediately once that happens. So as we experienced this a few times, we decided to provide the tooling and to create tooling that would both compress and transport the logs once that happens, and also within the framework itself to have log filtering and very basic log throttling. Finally, we Dockerized our simulation packages, runtime packages, so they can be run on Kubernetes, both locally and on the GCP Google container engine. And we recently started evaluating a service by Google on GCP called distributed load testing using Kubernetes. It's basically a service that is provided with a runtime package for Gatling, and it distributes it over a Kubernetes cluster on the GCP. And it runs seamlessly, so you don't have to do anything else. That it comes out of the box.
That's to replace the Red Light 13?
It's an addition.
Okay,
It's an additional strategy that we want to adopt.
okay, well, basically it does the same.
It a little differently, but generally, yeah, it reaches the same output. Yeah. Since we got so much impact, so much positive impact, and so much attention from the usages and the amount of bugs, critical bugs we found very early on, and were able to fix before large customers rolled out to our product. We realized very early on we were onto something very big, something that's of amazing use not only at LivePerson, but also to other organizations. So we decided to go on and extract out of our platform a framework, and we are working now on open sourcing this framework. It should be available within a month, taking into account the October holidays. So it should be available within a month on the LivePerson account. Now, this framework, as it does here at LivePerson, is capable of doing anything from enhancing Gatling to provide small standalone simulations onto really enormous simulation platforms that can serve even the largest software as a service organizations. Tooling that comes with the framework will follow afterwards onto GitHub. So once you want to use this framework, you'll have all the automation, all the ease of use that we're able to enjoy here at LivePerson. And you can use that. You'll be able to use that as part of the open source. I'd like to encourage you to please use this project. Use these projects. Tell us what you think about them. Anything we should change or not. Contribute if you think you have anything to add. We really welcome you into this community, and we want to make this framework even more awesome than it currently is. I'd like to transition to a demo now to show you how. Why isn't it working? Just a sec. Where's the mouse? Okay. So this is a video recording. This is a video recording of a test run that was conducted yesterday afternoon. This is a recording and not a live session because it took an hour to produce this simulation, and I don't want to keep you waiting for an hour for no reason. So it's a completely unedited video. It's basically a single machine in EC2 Sydney, generating traffic against a LivePerson data center in Sydney onto a service, a LivePerson service called Shark. It produces 4 different API type calls, 10,000 users. What this script is doing now is running a Maven test command on the on the platform runtime package, because Gatling runs over Maven commands, and this runs on the background, so you can see process number on this machine. So let's quickly start. and see what happens. As you can see, there are four, I hope you can see that, there are 4 CPUs on this machine and almost 8 gigabytes of RAM, which is far more than we need to be able to run this kind of a simulation. Every 5 seconds, Gatling generates a table onto the console, and this is what we see here. I hope you're able to see there are 10,000 users pending start at this point at the beginning of the test. Afterwards, 5 seconds later, 83 users are already active. 5 seconds later, 167 users are already active. And as you can see, requests are starting to be generated on the 4 API types. And as you can see, the number of requests is growing at every 5-second interval. And it would take 10 minutes exactly for all the users to be loaded. So as you can see here, at 600 seconds, 10 minutes exactly, we have 10,000 users, while a moment before we had less. So at this point, we have around 400,000 requests in total. Let's jump a little forward, just so you're able to see how this goes. We're around the middle of the simulation. Stop. We're on the middle of the simulation, and as you can see, there are already around 2 million requests generated so far. The load average on this machine at 5 minutes is 0.26, which is an extremely load average. Around 53% CPU at this time, and the maximum would be 400. So it would be safe to run probably as much as 4 times the amount of load that's currently run on this machine. So quickly moving forward to the end of the test, you can see a report was generated. You have a few statistics of the run, and then you have a link to an HTML file of the report itself. So let's quickly look at the report. It's an HTML file, so you can see it here. This is the actual report of that test run from yesterday. So what you see here is a distribution of response time. You can see the percentiles. In this test run, even at the 99th percentile, the response time is extremely low. So you can see it here. You can see the amount of successful requests, the amount of failed requests, the requests that return errors. There are none. I hope you're able to see the response time distribution is almost entirely around 8 milliseconds. You can see the response time percentiles over time. You can go through the graph. You can zoom into any specific part of the graph to have a more granular view of what happened during that test. You can see the number of requests per second during the entire test run. Also, you can zoom into any part of that and see what are the values at any point in time. You can also zoom into a specific request type. You can see all the requests of a specific request type. Now, let me zoom in. Right. So as before, you can see the response time percentiles, and you can see the request per second. You can also see the the amount of requests per second average. So we have, for this request type, around 870 requests per second. Let me quickly return to the presentation. Cool. OK. So to my favorite part, the code. Most of the examples I'll show here are basically from the framework itself, the framework that we distilled from our platform, the framework we're open sourcing at the moment. The framework itself, the repository, contains examples. And we use some of the examples on the framework on these slides to make it clear. And so when it becomes available, you're able to come back to those examples, to the same examples, and see how this runs in runtime. So I'd like to go over basically the basic features of the platform for which this platform was created. And I'd like to start with the main components, the main 4 components of the platform. Right, so let's start with scenario. A scenario example you can see here on the top screenshot. Can you see the mouse? Yeah? Okay. So scenarios are basically assemblies of building blocks, which means they combine building blocks, which I'll describe in the next slides, in order to create a complete user flow that you would like to reproduce in your simulation. So what you can see here, for example, I hope you're able to see, is we're calling in two instances, we're calling a class called complex example blocks. Complex example blocks is of a block type. Now, a block type is also one of the main component types of the framework. And what a block does basically is allows you to group into into a code snippet, basically a number of either blocks or other more lower level types. So basically, if you're a development team and you own a service and you want to provide simulations to other teams, the way you'd expose how to simulate traffic over your services is you'd create a block that would expose all those common and correct ways to interface with your service. For example, here you can see there is a call to a request and then another logic part. And here you can see there is a call to a different request and then a different logic part. We'll reference the logic parts later. So that way, a service owner is able to expose those basically those snippets, and they basically perform as reusable code parts that can be reused in other blocks and in scenarios to compose real user flows later. Now, scenarios can contain logic parts like, for example, loops. As you can see, there is a type of a loop here called repeat, which means repeat for 100 times the code contained in this block. It can contain also conditions, if this do that or else do that, cases, and so on. It can contain loading of data from data sources, and also custom logic. All scenarios inherit from scenario base. If you don't inherit from scenario base, you're not able to select this scenario to be able to run on the simulation runtime. And what this method here that you see called build scenario outputs, which is a requirement for any scenario class inheriting from scenario base, is basically a blueprint that will be used later by the Gatling runtime engine for every user that will run the scenario as a kind of a template of what this user will run. Now, as I said, this is a template and a blueprint. As you can see, it's static. It's stored in a value, which means it's unchangeable, immutable. Now, if we want to provide variance, we don't want every user to do exactly the same thing. Well, not in every situation. So we need to provide variance. The way we do that is via a key value data store that Gatling provides called session. So we save data into the session and we read data from the session. And through this key value store, we're able to create variance in the way this interacts. So, for example, a loop can repeat if something happens, or does not repeat if something doesn't happen, or the amount of repeats would be defined in a specific session key, and the same for conditions, and the same for any other logic flow. Right. So this is, I hope you can read this. This is an example of the beginning, the first fifth of a live person scenario, a real live person scenario. I use this example here to demonstrate that this framework that this is based on is really capable of handling really as complex scenarios as you can generate, or as you will need, basically. As you can see, I hope you can see, there are blocks used here all over, from the beginning of the scenario and throughout the scenario. So this allows for modularity, which means our development teams provide blocks. We use them all over as parts of, as building blocks for assembling our scenario. And as you can see, almost everything else other than the blocks is either logic, which means loop, conditions, data processing, and so on, or working with session, reading from session, writing from session, writing into session, sorry. Okay, the next component of the framework I'd like to reference is the request type. A request is really a very low-level building block for the framework, which allows you to define activities directly associated with HTTP or HTTPS requests. So if you want to make a request to a specific HTTP API, you would simply create a value called request on a class that extends request base. You would specify what is the status you'd need to this API to return. It's kind of an assert on a test. And you'd combine it, kind of bind it or couple it to a request predef class, which is the fourth element, the fourth component of the framework, of the main ones. And this request predef here, the complex example, step 2 predef, is the same one here. It's from the same example. And through this predef, you define the HTTP method. If you want it to be get or post or delete or put, you define the host, the base URL, the HTTP headers, the query parameters if you have to. If you don't, there is a default empty list of query parameters. And what happens when you call on the request type, when you call the get HTTP request builder, it infers all that information as a result of the coupling to the predef class, as those are, you're obliged to provide all of them. So it infers them, and you don't need to explicitly provide those as arguments to the get HTTP request builder. So you have metadata of the requests in one place in the request predef, and you have all the request logic on the request component. In addition to the request value itself, you can have all kinds of session manipulation, for example, parsing the response or preparing the session for the request itself. For example, if you can see this part here, this is, can you see this? You're able to read? Okay. We're attaching to a part of the URL itself a session key in curly braces with a $sign prefix to it. This allows us at Gatling test runtime to read from session key, from the session key specified. It basically replaces this text with the value that's assigned to that session key at session of that user. And you're able to get a variance in that way. So you're able to, for example, add a function here at the request type and specify any request you'd like to, any, suffix you'd like to have here. and that suffix will be appended to the HTTPS // host, and it will be used there. At this example, you can see that at the blocks level, it basically prefixes the Wikipedia's most recent change. So it would also always go to the latest updated Wikipedia page. To quickly go over the project structure, the main module for this framework is the core module. The core module contains the framework's base types that we specify: the scenario, the request, the block, and so on. It contains several Gatling extensions and enhancements. It also handles parsing of the parsing and validation of the configuration JSONs. It provides DSL types of the framework itself, such as the get HTTP request builder. It also provides a lot of useful utilities that you can use for simulating traffic and doing a lot of automation for you, so you don't have to work it out for yourself. And it also contains a small repository for all the framework's core session keys. So you'd have them out of the box, and you would not be able to override them or try to push session keys that are already used by the framework itself. The other two module types are additionally important because this is used as an example. So you'd probably take this as a pattern to use in your own organization. So all the modules prefixed with module dash are modules that would normally in your organization, and the same at LivePerson, would be in a different repository. They would contain only reusable code, which would be the components that we talked about as block, request, and request predef, and only those types, because they must contain reusable code. And once all those modules are in the same repository, this can be used as your platform, as your shared platform. So everybody can basically access it and pull content from there and run simulations using that code. The final module that you can see here, where's the mouse? Okay, sorry, are the scenario modules. The pattern that we recommended to use is that every development team, or basically any team that would like to use the simulation platform, would have their own repository that would contain this single module that would have a dependency on the platform modules that it would need to use. It doesn't have to use all the modules, just the building blocks that it would need to assemble scenarios from, and the framework dependency as a dependency. And this module will only contain scenarios, configurations, and the CSVs that you would want to be using. You would only have the scenarios you'd want to run for your team, and that would allow for more manageability. So if you need something specific for you, you don't need to share it with anybody else, and you don't have to have a shared repository of scenarios for everyone to use. One more thing is that we advise that the platform, meaning the modules that contain all the reusable code parts, be in a kind of a CI, in a CI procedure, which means you need to have tests to validate the code there is correct, you didn't break anything for anybody else. And when all tests pass, you'd get a build. The build jars would be pushed onto the Artifactory of the organization, and everybody would be able to pull from their scenario modules those jars and use them seamlessly on the new version generated by the build, the snapshot, or the release, whatever. The last slide of the code demos. I referenced all the basically the code parts themselves. Now, to be able to define what runs in a simulation runtime, you'd need to have configurations. Configurations specify, for example, the duration in seconds of the entire simulation. They would configure all the scenarios that are runnable through this simulation. For example, you can see we have two here. You have a simple example scenario and we have complex example scenario. Both are scenarios that are present in that module, in the module that contains this configuration. And per scenario, as you can see, it's inside the curly braces of this scenario. You have user ramp-up stages. So you can specify, OK, I want to start with 10 users that will ramp up over 20 seconds and then wait for 30 seconds. And then after 30 seconds, I want to ramp up 10 additional users over 20 seconds. And the overall 20 users will stay and run the load for this scenario for the duration of the simulation. You're also able to set various types of settings, custom settings for your scenario. Settings of various types. You have string types, you have Boolean types, integer, double, array, range, and map. So you'd have all the types of settings all the granularity of types of settings that you can specify to configure your service simulation to run as you need it to. And you can also specify CSVs, data files for your simulation scenario to use at runtime. For example, if you need to have your scenario log into something, you'd need credentials, and the CSV could be used to provide that for you. Simulations can have more than one configuration file. For example, in the example that I showed of project structure, there is a module containing scenarios, and this module can contain more than one configuration file. It could be used, for example, if you have multiple target environments. You'd want to go against once a test environment, and then a production environment, and then a different production environment. And it could be different in terms of the scenarios you'd want to run, the number of users, the ramp-up stages. And in addition, there is an environment settings section here below that looks exactly like the scenario settings part, except that it doesn't have default values. And those settings are available to all scenarios runtime. It's completely generic. It's not like the scenarios themselves. Basically, all the information here, all the settings here are available to all scenarios. A scenario itself, for example, a complex example scenario is able to access, I hope you can see here, it can access scenario CSV dependencies, which would be this file, and get the example key, which would provide it the CSV itself, that it would be usable. And then you can go scenario settings and get by key a string. It would know within the complex example scenario itself, within that class, that it is the complex example scenario and not a simple example scenario, and get you the settings of that file. So you can pull a setting as string, you can pull a setting as map, for example, or as range, or as any type currently supported. Now, as powerful as this configuration is, it's not very welcoming if you want to create a new environment, or if you want to, on a current environment, you want to have a different ramp up and a different duration, select different scenarios. It's not a trivial thing to do unless you're very accustomed to how this JSON is structured. And to be able to make this really easy to use and make this even a seamless experience for our users, we created a tool in-house to be able to have everything configured and packaged for you. And I'd like to welcome Asher to discuss this tool with you.
Okay, so hi everybody. My name is Asher, and I'm a traffic generation infrastructure engineer, currently holding a student position here at LivePerson. Well, yes, as Ori previously described, our platform is based on Scala, a functional and immutable language. And as someone who didn't know Scala at the time and understood the need for a way to ease the use of our platform, with the help of Ori, I created a web application that by supplying the user's company GitHub credentials, then choosing a release of our platform, then selecting an environment, a scenario, and by supplying other settings such as test duration, and when I say test, I mean duration, he will be then able to download a compressed archived file containing our platform. This platform will be, of course, be configured with the user-provided settings, and he will be able to run it with one-click too, with the use of a script. For example, let's say that we have a developer, the intelligence department, let's call him Jeff. Jeff supplies his GitHub credentials. He then chooses a specific release. According to that release, by the way, a release of our platform, according to that release, he chooses a target environment. He then, out of a list of scenarios, Jeff wants to run 2 different scenarios at the same time with different parameters. And he would like to run this whole simulation within an hour. Well, as you can see, Jeff will be able to do so pretty easily using the web application. Yes, so in addition to this, Jeff will be able to save the current configuration of the web application and then loading it directly into the web application at a later time. Or if he would like to, he would be able to load it into the terminal due to the fact that our backends API is open to CLI commands. Well, all this, as you can see, Jeff wasn't required to know Scala. He wasn't required knowing the platform structure. He wasn't required knowing configuration schemes, Maven commands. He wasn't really required knowing how to code, okay? So all this was made in order to help and support around 80% of the times that our platform is being used. And well, yeah, so in conclusion, I'd say that this tool does a great service to most of our platform users, and will hopefully potentially attract many more in the future. Well, at the end of this talk, those of you who would like to stay, Ori and I will stay as well. We'll take questions, comments, discussions. We'll gladly stay here to discuss this framework. By the way, those who want to catch up with the platform, our mails are on the board. We'll gladly keep you updated with the open source project. And those of you who would like to contribute to the open source project, please mention it in the mail. Well, as any important open source project, what really makes it stand out is the community behind it. So Ori and I would like to encourage you to join this community and take part of with the open source project. Well, thank you all. We hope you had a good time, and we're open for questions.
Let me ask you about the web interface.
Yes.
Basically, I can now go in there and start a test that will spin up a bunch of machines in Amazon and cost you, and you have some kind of protection against people who If I now start a test for 24 hours with a bunch of users,
Well, yes, it's first of all, it's all HTTPS. It's not HTTP.
no, but I mean by accident. I'm a developer. I want to start a simulation by accident. Instead of doing
Create a
3600 seconds, I do 36,000 seconds.
Okay, so yes, we have a protection against that in the front end and the back end as well. And we were thinking about adding another protection inside the configuration itself that we previously shown. But yeah.
It will tell you what are you crazy? Something else?
Pretty much. If you'd like, so you can go to the JSON file, the configuration, and change it yourself. But it's your responsibility. Yes.
I'll add something. I'll speak to the microphone so it's available in the video.
Yes.
The configuration change Asher referred to is basically limiting the amount of users you're able to spin up in a Gatling run to what's available currently in the repository basically at the source control. So if you're authorized to start I don't know 100 amount of users on a specific target environment, you'll be able to do that, to spin that up. And if you're not, you'll simply have to ask someone to change the limit for max users, and in the GitHub in the internal GitHub repository.
No, I was talking mostly about accidental, because
I know.
nobody will do it on purpose unless they modify it. Sometimes you forget the zero and just.
I understand, but you're talking in terms of cost. I think the more dangerous thing is to accidentally generate a huge load on the system, because the cost, to be frank, it's almost insignificant. I mean, no matter how much traffic the user will spin up, it's really not that costly. And we're able to take that into account. But it's more dangerous if user, I don't know, accidentally generates a million concurrent users load on a specific service on one of our data centers. That's something we had to take into account, and that's the reason for the limit in terms of user numbers.
So if I choose the right environment in production, I can bring down 9%.
You'd have,
yes.
yeah. Technically, yes.
Any more questions?
Nobody else? I was talking about the management of it all. I mean, when now a new service has a new API endpoint, or there is a new service, when do you write the simulation, and who will add it to the main simulation that does the entire flow? I mean, who is responsible for it? Will the service get into production without a simulation?
Would like to?
Can you please repeat it so I repeat it to everyone?
The question was, when a new service or new API endpoint is being built now, when do you write the simulation? Who writes it? Who adds it to the main flow?
Right. So there are two parts basically that assemble a project. There is the framework itself, which is completely agnostic even to live person, right? Because it's going to open source. There is the part of the platform itself, which contains all the building blocks, the requests and predefs and so on. And there is the part of the specific teams that have the scenarios themselves. That it's actually the runtime is there. What you're talking about in terms of adding services, a team that adds a new service, as it's in their ownership, would need to add new simulations to the platform, to the group of modules that contains all the service simulations, all those building blocks, right? So it's in their responsibility. Sorry?
But is it mandatory to get into production?
No.
Or is it
No, it's not. It's not. It's not. But it's really in their best interest. So they would be able to simulate traffic, and other teams that become dependent on their service would be able to simulate and really seamlessly integrate into.
But I'm as a developer, I don't care about other things. I trust my service to work.
Well,
What's my?
It doesn't work like that at LivePerson.
No,
Yeah.
I'm saying,
Okay.
I don't really see the value as the developer to. I I mean, I see the value as the company.
Well,
the ops guys.
I would hope your team leader would see the value.
That's also
Yeah, so that's the answer.
semi-mandatory. I mean, you don't force it, but the team leads will hammer you down if you don't do it.
Yeah, hopefully, yeah.
The team is responsible for the resilience performance of its company. So anyway, they need to do it.
It's better if they do it.
Yeah, the same way you have a design review, a security review, a resilience, a performance review. This is part of the review. You'd need to present results that say, okay, in terms of performance, this is what we get, and this is what we expected. In terms of resilience, this is what we get. You need your builds to be green in terms of acceptance tests also. And this is a very major part of an acceptance test because you see how the service integrates in the whole system. Right? We're talking about small microservices in a very large system. So you need to know how everything integrates.
And that's basically the integration testing as well. You don't have anything else?
It's called acceptance testing. It's a later phase basically of testing.
First time where a bunch of different services meet?
No. This is simulation of real user traffic. It's a much more complete test. And basically, when you get to that test, you expect everything to be green as possible. So it's just kind of a verification phase. Anybody else? We're hiring, by the way. So thank you all. Thank you very much.